Good morning. This is your stats sensei, Mr. Spensei, and we're going over the last quiz on experimental design. So slips and falls are very dangerous to the health of individuals. Concerned about the dangers of slipping and falling, researchers at the American Podiatry Society are examining two different types of materials for shoe soles. The sole is the bottom of the shoe or sandal and is the part that touches the ground. One shoe sole will be made of a PVC material while the other will be made of a rubber. Both shoe soles will have the same tread pattern. The materials look and feel differently. All right, so they look and feel differently, so we can tell that there is a difference in them. All right, so they are visibly different. Initially, the researchers wanted to conduct a match pair experiment with 100 volunteers, design a match pair for the above scenario. First off, one of the things that came up is design doesn't mean just draw a diagram. Design means explain. Drawing the diagram is great and can help explain some of what you've done, but the diagram itself is worth no points. In order to get the points, you have to explain in words. So I defined treatments. I didn't have to define them out, but it just makes it easier. Treatment A, group wears the PV sole for a month and then wears the rubber sandals for a month. Treatment B wears the rubber sole for a month and then wears the PVC sandals for a month. And you're going, well, why didn't we do like we did with the waterproof boots and put one on one foot and one on the other foot? The reason we couldn't do that is they look and feel differently, so we know which treatment is which. Further, if you're slipping and falling, you have to wear the same shoe at the same time. So you'd have to wear all PVC or all rubber. The reason being is otherwise you wouldn't know why you were slipping. Matter of fact, if you're wearing both, it could be because you're wearing two different types, it was causing you to slip. So in order to identify what was causing the slipping and falling, you could not mix them together. So then I've said, okay, A was PVC first, then the rubber sole, and B was the opposite direction. So I would randomly assign the 100 participants to the two treatment groups by placing their names in a hat and mixing thoroughly. The first 50 names drawn would receive treatment A, and the remaining 50 names would receive treatment B. So that tells me the order. Subjects would record the number of slips and falls for each type of sandal. At the end of 2 months, we would collect the data to determine which sole was better at reducing the number of slips and falls. This was another thing that people lost a lot of points on. By the way, if you wore them at the same time, you lost 5 points. But the other thing that got people is when they went to compare results, they say, oh, and we'll compare results to see which is better. And you're like, better at what? And it's better at reducing the number of slips and falls. So it's really, really important that you tell us what it was that we were reducing. So with the waterproof boots, we're looking at wear. Here, we're looking at reducing the number of slips and falls, and you have to be very prescriptive in that. So basically, the assignment was worth 5 points, essentially. Actually worth a little bit more than that. Actually, and then this was with 5 points, and this was worth 5 points. So essentially, that's the way it broke out. Okay. Later, one group of researchers decided, and by the way, on part B, we did pretty well on this. Later, one group of researchers decided to conduct a randomized design with 12 volunteers. The researchers believe that slips and falls were related to the age, but not gender. Because researchers wanted the size of the blocks in an experiment to be equal to the number of treatments, they will use blocks of size 2 in their experiment. Identify the volunteers by number that would be included in each of the 6 blocks and include the criteria and justification for your blocking along with the blocking variable chosen. All right. Most groups did very well on this. They started off with the definition, which is what I do not have written down here, and I should. It should say that we block on the variable which we believe will have the greatest impact. Because researchers believe that age is a factor, I will block by age. That right there will take care of your criteria and justification that are closest in age in blocks. And I'm doing it regardless of gender. You did not need to say regardless of gender, but you should have had everything else. You should have had, I will block based on the variable that will have the greatest impact. And because the researchers believe that age is the factor, I will block by age by placing the volunteers that are closest in age together. And you could either list the blocks by ages or by volunteer numbers, and that was fine. So when we look at this, we see 22 and 20 are the closest. Well, that's volunteers 1 and 2. And if you had the ages and not the volunteers numbers, that was fine. You got credit either way. And then we say 10 and 12. All right. So what's the deal with 10 and 12? 26 and 28. And then 44 and 45 for 8 and 9, 47 and 47, 60 and 59, and 67 and 64. All right, whether you blocked it by put the age listed or the volunteer number, either one of those were accepted. You do not have to have both. Some people just labeled blocks 1, 2, 3, 4, 5, 6 off to the side, and they made little boxes. That was great. So if you did something that looked like this, 1, and then you went 1, 2, that's awesome. As long as you said put a label that said that was a block. Okay. All right, most people did pretty well on part B. Part C, once again, people did pretty well on part C overall. Another group of researchers believe that slips and falls differ with both age and gender. These researchers will also use blocks of size 2 in their experiment, identify the volunteers by number that would be included in each of the 6 blocks, include the criteria and justification for your blocks, along with the blocking variable chosen. Once again, students started off with the definition. We should block on the variables that have the greatest impact because we believe age and gender are both factors. We will block by them first, by them. And generally speaking, it's better to block by gender first. So we're going to make a male block and a female block. Here's my female block. Here's my male block. Everyone in this group are females. Everyone in this group are males. Within the female block, it's like, okay, that's my youngest female is at 22. My next youngest female is 26. So the youngest and then the oldest are matched as well. If you had volunteer numbers, full credit. If you had ages, full credit. You did not have to have both. Some people did, and that was great. So, anyway, because the researchers believe that age and gender are both factors, I will block by gender first. It just, as a general rule, it makes it easier to block by the gender first and then block by whatever the other variable is second, which in this case was age. All right. Okay, so that's the explanation for that. And please remember, when you're doing these and whenever you're explaining things, you have to assume the reader doesn't have any knowledge on statistics and you have to give a full explanation, okay? They're not unintelligent. You have to assume that they're an intelligent person, but they don't know anything until you write it down, okay? All right, part D was a struggle for us. This is one of the places that we lost a lot of points. The researchers in part C decided to select 3 of the 6 blocks to receive the PV soles and to give the other 3 blocks the rubber soles. So we are blocking. Is this an appropriate way to assign treatments? All right. Please note, we're not doing a match pair design here. If so, describe a better method for selecting the 3 blocks to receive the PV soles. If not, describe an appropriate method for assigning treatments. All right. So, if this is, since we're working with blocks, we don't get to switch it over to match pairs, and most people switched it over to match pairs, and this lost a lot of points. If you switch it from a blocking to match pairs, you lost 10 points. So no, this is not an appropriate way to assign treatments. How do you supposed to try and assign treatments? Randomization of treatments must occur within each block. All right. So you need to put a big star and know this. Randomization of treatments must occur within each block, and each block should receive both treatments. Not each person in the block but we're randomly assigning within each block. So essentially, when we block, we make sure that we put volunteer 1 in a hat, volunteer 1 and 10 in a hat, mix and draw. And then volunteer 1 might get the PVC and volunteer 10 might get the rubber. All right. So then you need to explain how to do it. To assign the treatments, I would select one block and put the number of the 2 volunteers in a hat and mix. Some people flipped a coin and that was fine. The volunteer whose number is drawn would receive the PVC sole and the other would receive the rubber sole. I would repeat this process for each of the 6 blocks. Do remember, if you flip a coin, you have to make sure that you say what heads is and what tails is. So you have to give both options and be very specific on it. All right. So that's why I think it's easier just to put the 2 numbers in a hat and mix, but you don't have to. There are other ways to do that, and coin is certainly one. Okay. Once again, this part D was a real struggle. So on question 1, this first page was rough because a lot of people drew diagrams with no explanations. Others forgot to tell us what we'd be measuring, which is reducing slips and falls. And then we also lost points because we were trying to wear both at the same time. Okay, moving on. There are more than 100 species of poison dart frogs. A scientist for a small tribe in the Amazon is interested in studying whether the different insects eaten by frogs at different humidity levels in water impact the toxicity. Oh, guess what? That's what we're interested in. And we have insects and humidity. The scientist has ordered a large shipment of young gold poison dart frogs from a supply house, and we only have poison dart frogs for use in the study. The experiment is to be conducted in a laboratory, and the frogs will be randomly placed into 6 similar tanks in a controlled environment. There are 198 poison dart frogs available for the study. The scientist is planning to use 3 different types of insects, crickets, flies, and grasshoppers, and 2 different humidity levels. All right. List of treatments that the scientists plan to use in the study. If you just said the 3 different types of insects, crickets, flies, and grasshoppers, and 2 humidity levels, you got no points. The treatments are the combination, which is crickets with high humidity, flies with high humidity, grasshoppers with high, crickets with low, flies with low, grasshoppers with low. Each one of those with 1 point, you needed to show the actual listing of the combination. You have to show the combination. You can't just rewrite this that was in the sentence prompt or in the scenario prompt. You have to put it down as the combinations in order to receive credit. A lot of people or several groups made that mistake. All right, so now I want to describe a completely randomized design that will allow scientists to compare the frog's toxicity. All right, so once again, we're designing, and it says describe here, but you can use a diagram, but once again, you have to have the words. So I'd number the frogs 1 to 198, place corresponding numbers on separate pieces of paper, and place them in a hat and mix well. The frogs associated with the first 33 numbers drawn will receive the high humidity. The next 33 will receive high humidity. Cricket with high humidity. The next 33 will receive cricket and low humidity. The next 33 drawn will receive flies and high humidity. Continue the process until 33 frogs are assigned to each of these 6 treatment groups. All right. Some people work this from the tanks, and they number the tanks 1 to 6, and that's great. But you have to be very careful on how you do the explanation Okay, so you randomly assign the treatment and you randomly assign the frogs. That's fine. But you have to make sure that you do a good job following it. And if I had to read it 3 times, there's several of them I read 3 times and I had no idea what you were trying to say. If I can't understand what you're saying, you don't get credit for it. All right. 6 points for being able to describe that. The next one, give one statistical advantage to having only poison dart frogs in the study. Explain why this is an advantage. Now, this is tricky because it was easy to get 5 points, but um, but 10 points was a little more difficult. Using only poison dart frogs reduces variation, and that was the key word. We're not talking about confounding. And by the way, don't use the word confounding or bias in a problem unless you're ready to do the whole explanation of it. So if it's an FRQ and you're mentioning the word confounding, you better be using the confounding sentence stem, that whole long sentence stem. So don't use it unless you're don't use it unless you're gonna don't use confounding unless you're gonna use that sentence stem. But so it reduces variation that might exist due to biological factors or differences between species of frog. All right. As a consequence, we'll be better able to determine which treatment produces the most toxic frog. All right, that was the second thing. So we needed to have this, and we needed to determine what it. We know what we're better able to determine what's making the change that we are seeing, because that's what we're interested in, is in toxic frogs. Part D, to which population can this be generalized to, if any? Justify your response. Again, easy to get 5 points, hard to get the 10 points. The study can only be generalized to the golden poison dart frog, as it is the only frog in the experiment. Okay, most people did pretty good with that part. The part that was missing was, and other frogs are likely to have different responses to the treatments. All right. So you have to have both parts. One is the golden frog, because that was in the experiment. And the reason other frogs could not be included is because they may respond differently. All right. And I wasn't even specific as to what it was. They may have different responses to the treatments or different toxicity responses to the treatments. But the main thing is the other frog type species may have different responses. If the results are found to be statistically significant, can we conclude that the experiments do and the treatments do impact the toxicity of the frog? Justify your response. All right. So once again, this one was actually, we did reasonably well on, but there's a key word that a lot of groups left off. If the results are found to be statistically significant, we can say that the treatments do impact the toxicity of the poison dart frogs. And people did really well with that because this is an experiment in which treatments were randomly assigned. If you just had, because this was an experiment, we can say that it's impacts the toxicity because this is an experiment. That was great, but you needed to tell me that this was an experiment in which treatments were, or this was a treatment, excuse me, because this was an experiment, and as such, because this is an experiment, we can show causation. I apologize for a little bit of the stuttering this morning, but a little bit on the tired side. I thank you for joining, and as your stat sensei, I hope to see you on the next one. Good luck to you guys. Thank you.